Alright, ladies and gentlemen, this is going to be our next video on mixtures. So let's get started on this next video. So what is a mixture? Well, let's try to go through and remember what an element is. So let's say these purple dots here represent an element. Now an element is the smallest unit or the smallest unit of matter, and these purple dots represent what we would call an element. Now a compound is when multiple elements come together and then they go through and form a molecule. So this box here would represent compounds. Now, if we were to take elements, compounds, and different compounds of different compositions and put them all in the same rectangular box, well, this would be a mixture. So a mixture is a substance composed of two or more elements or compounds that are mixed together but not chemically combined. And we can see in the box on the right, none of it's chemically combined, but they're all in the same box. Now, mixtures and examples of mixtures are going to be something like salt and pepper, sugar and sand, salt and sand, maybe the Earth's atmosphere, maybe soil. So maybe trail mix is an example of a mixture. Chocolate milk would be an example of a mixture, the milk and the chocolate. If we're thinking about a chocolate chip cookie, well, we have the cookie, which is the flour and the sugar and the yeast, and then also the chocolate chips that exist on that cookie. So a mixture is a substance composed of two or more elements or compounds that are mixed together but not chemically combined. When we're going through and talking about mixtures, well, there's a little bit of confusing vocabulary. We have the words solution, solvent, and solute. And students commonly get these three S words kind of confused and they don't necessarily understand what they mean. So let's go through and look at this confusing vocabulary. So let's start off here. We have a solution. Now, a solution is a liquid mixture in which the minor component, the solute, is uniformly distributed within the major component. So if we go through and look at it, well, the solute, this is what is being dissolved, whereas the solvent, well, this is what's going through and doing the dissolving, or what is going through and containing the solute. So let's say we had a glass, and I put water in that glass. Well, if we go through and add salt to that glass, what's my solute and what's my solvent? Well, in this case, the water is the solvent. It's dissolving the salt, whereas the solute or the salt is what is being dissolved. So our solute would be the salt and the solvent would be the water. Now, the glass with the water and the salt is the actual solution, or it's the liquid mixture which we're talking about, the solute and the solvent combined. So let's think about water as a universal solvent. Well, water is capable of dissolving a variety of different substances, which is why it is such a good solvent. It's called a universal solvent because of its polar properties and because it dissolves more substances than any other liquid. So let's go through and look at this and understand why water does this. Now there's a couple vocabulary words we have to understand. So a substance that repels water or is afraid of water is going to be a nonpolar molecule. And we call that hydrophobic. Hydro meaning water, phobic meaning afraid. Now, a substance that is attracted to water is another polar molecule, and we give it the vocabulary word hydrophilic. Hydro meaning water, philic meaning loving. So phobic means afraid, and hydro means water, and philic means loving. So if we were to look at a hydrophobic, if we were to look at wax in contact with the water, well, it's going to force the water and the molecules to kind of be repelled away from the surface of that hydrophobic surface, or the wax, because it's non-polar. Whereas if we were looking at the hydrophilic surface, well, both the polar molecules of the water and the polar molecules of whatever that hydrophilic surface are attracted to each other, so the droplet's going to be more spread out. So an example of something that would be hydrophobic is the waxy cuticle that you see on leaves. And leaves go through and have this waxy cuticle to keep the water inside and then regulate the water that's going in and out of the leaves of the plant. So remember, polarity and hydrophilic are related. So water is a polar molecule, and remember, it's because of uneven sharing of the electrons between the covalent bonds that exist in the water molecule. Remember, the electrons are spending more time around the oxygen, so therefore we have a partial negative charge on the oxygen and a partial positive charge on the hydrogen. So hydrophilic molecules are also polar. If we have a water molecule, which is polar, and water and other molecules that are attracted to each other, well, then they also, likes dissolve likes, and they have to be polar. So they also have to be polar. Now, in this case here, we can break this down. Polar dissolves other polar molecules, and nonpolar will dissolve other nonpolar molecules. So we can see, well, salt is ionic and it has charges here, which is why the polar charges in the water will go through and dissolve the sodium chloride. So let's look at salt being dissolved in the water. Let's say we have a crystal of salt here. When we place the salt in the water, we're actually going through and separating the chlorine, which are the green molecules, from the sodium because of the negative charge. So when salt is being dissolved, well, the positive charge of the hydrogens that exist on the water molecules are actually plucking off those chlorines and separating the chlorines and the sodiums from the actual salt crystal and dissolving it in the water. This is why the salt disappears when you go through and place it in water. So there's two types of mixtures that we have to talk about that are related to solutions, solvents, and solutes. So a homogeneous mixture is one in which one substance is dissolved in another. So an example of this would be like a solid or a liquid or a gas. Now we have uniform distribution when we're going through and talking about homogeneous mixtures. So an example of a homogeneous mixture would be sugar and water, salt and water, maybe hot chocolate, Kool-Aid, teas, or alloys. And it's where one substance is dissolved in the other substance. Now a heterogeneous mixture, well, this is where a mixture of water and non-dissolved materials will go through and create a heterogeneous mixture. So we do not have uniform distribution. So an example of non-uniform distribution or heterogeneous mixtures are going to be blood, oil, and water. And this has to do with non-polar and polar in the case of water and oil, and potentially blood and plasma. Now, the reason that we see non-uniform distribution is because the charges amongst both the solute and the solvent are different, and it's not going to allow them to mix in a way that's going to create that uniform distribution that we see in homogeneous mixtures. Now, again, all of these properties can affect the phase change of water molecules and the phase change of other liquids as they go through and move from a solid to a liquid to a gas. Objects that have lots and lots of hydrogen bonds and lots of polar properties are going to have higher heat capacities and are going to boil slower than objects that do not have polar or hydrogen interactions. So if we were to compare water and alcohol, well, water is going to boil much slower than alcohol because the water has hydrogen bonds, therefore has a higher heat capacity, and therefore the molecules will hold together more and they require more energy. So did you guys learn? Well, did you learn a couple of things? Did you learn the difference between solution, solvent, and solute? Do you guys understand what a mixtures are, homogeneous and heterogeneous? And do you guys understand why water is a good solvent? This will be the end of the video. I will see you guys in class tomorrow.